Hello everyone, this is video 10.3 where we're going to be looking at circles and spheres. This is a continuation of what we've been looking at in 10.1 and 10.2, really more 10.1 than 10.2, but a lot like 10.1, a lot of vocabulary, a fair amount, probably not as much as there is in 10.1, but still an awful lot of vocabulary. So make sure you know all the vocabulary for 10.3 before going on 10.4 and especially into chapter 11. It can be a lot of it. So let's get started. So we'll start with a circle. So a circle is a set of points. Now, this can already be confusing for some students who think of a circle as just being one object. But just like how a line is made up of points, so is a circle made up of points. And the points are defined by a given point, which we call the center, which lies at, well, the center of the circle, and then a fixed distance. So the center is fixed, which means it shouldn't move. The distance from the center to the points on the circle, that's fixed. It shouldn't change. And so when we take all those points together, then we create our circle. So we've already sort of defined the next two terms in the course of defining the circle. We've got the center, which is that fixed point in the middle of the circle. And then we have that distance from the center to the points in the circle, which is called the radius. Now, if we were to draw this, so we have our center here, and then we can measure out from here. There's a point in the circle. We can measure out. Here's a point in the circle. We can measure out. Here's a point in the circle. And as we do this, we get all these points. So what we're doing when we're drawing, and I'll do this in blue so we can kind of see, when we draw these points to make this circle, what we're doing is we're connecting all these points together. But each one of these points on the circle, we could measure it out from the center and see that it's the exact same distance there. So again, like I said, for a lot of students, they think of the center as just being one object, and you might think of it as being one object. Getting students to think about a circle as a collection of points can take some work, can be a little bit of a reach for some students, but it's important for them to understand that, so now we can start to work with a circle in a little bit more flexible and constructive way. The plural of radius is radii, three syllables there. So try not to say two radiuses. That's not really a word. I don't know that anyone's ever said one radii. That doesn't seem to come up very often. But radius is a singular, and then radii is the plural. The diameter is twice the distance of the radius, so it'd be two radii together. And it's specifically two radii that go across the circle. So if we have our circle like this, it's always going to go through, connecting through the center. So this one line segment here would be my diameter. So this would be my diameter across that circle. It's not a very good looking circle, but what can you do? But this is my diameter. It's also the longest distance across the circle. There are other ways we could go across the circle. We could go like this, and that goes from point to point on the circle, but it doesn't contain the center. So this is not a diameter. This is just what we call a chord. But anytime I connect one line segment across the circle and it contains the center, then we will get a diameter like this. So now to contrast, let's go from the circle to the sphere. The circle on the previous slide makes a point of it being in a plane. And so our circle is a flat object. It's only in two dimensions. It doesn't have any height or thickness or whichever dimension you want to use for your third dimension. A sphere in this case, however, is in space. It does have three dimensions. So whereas a circle doesn't have any height or thickness, a sphere does. So you can think of a sphere like a ball. It has height, it has length, it has width, it has all three dimensions. These other three terms, the center, the radius, and the diameter, they're all the same, but you have to think about how they're now going to be different in the context of being in space. The center doesn't really change. The center is a point. So a point on a plane or a point in space is still just a point. So you don't have to worry about that. The radius, however, changes a little bit because now instead of that radius just being that one segment rotating around that point on a plane, sort of like the hands on a clock, now it's operating in space. So now it can come off that plane, and instead of just rotating around in that plane, it can be going up or down or left or right. It can be going in all those directions. So it's that radius is now operating in 3 dimensions rather than just two. And the same thing for the diameter. It's now no longer just this fixed segment in that plane. It can now be moving up and down and left and right. So it can be moving in all different directions as well. So the three terms are the same. The idea is the same, but in practice, the radius and the diameter operate a little bit differently in space than they do just in the plane. So we have a tool called a compass that we can use for constructing a circle. We don't really have a tool for constructing a sphere because it's a little bit harder to do because it's in 3 dimensions. But this is going to allow us to draw the circle in a plane. There's really two parts to a compass. There's one part that is the fixed center. So on the top compass there, you can see that the little needle point at A is fixed at that center. And that needle's hopefully not going to move around or skid around. It's going to stay in that one place. And then we have our distance there, our radius B, which is the distance from the pencil point to the needle. That's our radius. And then as we turn that compass around, that pencil is going to construct all those points that make up the circle. The bottom compass works similarly. It's the same idea. The finger there is holding that little round disc in place. So that finger now is going to be the center of our circle. And then that white disc kind of rotates freely around the other part there, the pinkish part. And you see the pen is in that little hole. So as you rotate that pin around, the finger keeps it fixed. And so now we have that radius, which is now going to be the distance from the finger to the pin. So it's going to construct that circle as we go around. The bottom compass is called a safety compass for reasons that should be obvious. You don't have that needle that can, stick yourself or another kid or whatever. But these operate in the same way. You may see other forms. The book has a paper clip being used as a compass. One of my favorite professors when I was an undergrad had a piece of string tied around a piece of chalk. And yes, I'm old enough that they use chalk. And so he would have the chalk in the string and then just to hold the string at a certain length and use sort of like that other hand to keep that radius fixed, and then use the one hand with the chalk to draw the circle out. Really, anything that can fix a center and keep a distance can be used as a compass. So all of those work as compasses realistically. Okay, so the book talks about intersections of circles, and I want to go into this a little bit more detail. So I have a figure here with some figures. So we can see figure C and D, these two circles, that they intersect at 2 points. So they intersect at point B here, and then this point doesn't have a label, we'll call it G. So we can see that C and D intersect at 2 points. Now we also have this case here with D and G. And we see that D and G intersect at just this point here. So D and G intersect at 1 point. Now, this is a hard construction to do because if they're positioned in even like slightly the wrong way, it's not going to work. The centers of the circles E and F have to be on the same line with D. So these 3 points have to be on the same line. If I were to move E or F off that line, then they're either going to hit at 2 points or no points. If I move one circle closer to the other, then it'll become 2 points. If I move them further away, it'll become 0 points. So it's a difficult thing to make, and students are using compasses. If they don't know how to do the construction to make it work out right, they'll just take their compass and draw one circle, take their compass, draw another circle, and try to get it to hit at just 1 point. And odds are, because it's difficult construction to do, they'll either have the two circles missing or have them hitting at 2 points. So they might become convinced because of the difficulty of the construction that hitting at one point just simply isn't possible, and that's not the case. So we can see here that it does work. It does intersect at one point. We also think about it here, circle C and D. If I start to pull these two circles apart, then this point will start to move this way, and this point will start to move this way. So as I start to separate those two circles, those points of intersection will start to approach each other, and they'll eventually collapse on just one point. Now, uh, that may not be convincing for a lot of students that eventually they will, and they may think it goes from 2 points to 0 points, but it is constructible. I've had students in the past for whom this idea that one point is possible or constructible, it's been difficult to convince them that it's the case. The other case, which is almost too silly to even talk about, is circle C and G, and these intersect at 0 points. And this can also be a tricky case with students because when we're talking about things intersecting, it sounds like they should, well, intersect. And so the idea that intersecting at 0 points is even something that we have to talk about seems kind of silly, but it is a case to discuss. Also, likewise, the book doesn't mention this, but there is one more case, and that is if we have circle C intersecting with circle C. And then these intersect at all points. So this circle on top of itself, well, every single point is going to match up. So it's not mentioned in the book, but I mean, if we're going to talk about 0 points, we're going to talk about all points as well. It is a possible case. Um, so students will see problems like this where circles and spheres and other polygons, other shapes intersect with each other, or it could be intersecting with lines. We can certainly talk about how many ways can a line intersect with a circle. We can see that it could happen 2 times, 1 time, 0 time. All points is not possible because the circle is curved and the line is straight. But these problems of how many ways can these two things intersect with each other do come up a lot in elementary and middle school math. So, as an extension of this, what could happen when two spheres intersect? I mean, we could see that 0 intersection points is almost trivially possible, the two spheres, because it's not touch. But could they touch at one point? Could they touch at only 2 points? Could they touch at only 3 points? So what are the possible cases? And then if it's more than 1 point, maybe it forms some sort of shape. So if it does form a shape, what shape would it form? And then also a circle and a sphere. This is a little bit harder of a problem because a sphere is a spatial object and a circle is a planar object. So you have to think a little bit more creatively about how those things could intersect. But how is it possible for a sphere and a circle to intersect? So how many different cases can you come up with? Um, there are some cases that will work for two circles that won't work for two spheres and vice versa. So think about what this would look like. If you have any questions about this problem or anything else in this video, make sure you bring your questions to class and we'll get them answered. All right, thanks.